Mr. Ashton going through Unit 2 non-calculated mathematics, which might be a good indication for what a numeracy paper might look like for Wednesday. Calculators are not to be used in this paper, so really good preparation for Wednesday. Okay, first question. Now you'll notice straight away it will say words to this effect on one of your questions, but it might word it slightly differently. It might say the words I know it's OCWs, oracy, communication, written work. It's the same thing, it's with 2 of these marks. This whole thing's at 7 marks. So when you're doing it, calculations need to be explained throughout, okay? So Miss Franks needs a total of £1,340 to buy a car. She already has £584 in savings. So I'm going to do 1,340, take away 584. And then once I've worked that out, I'll explain why I've done that. So we're going to get 6, 5, and 7. So subtract amount already saved, or something to that effect. Amount already saved. So £760 amount needed. Amount needed to buy car. Okay, so it then says she earns £1,260 per month. She adds 15% of her salary from each month into a savings account. So I need to find 15% of 1,260. So I'm going to start off finding 10%, which is easy. Just take off a 0 divided by 10. And then 5% must be half of that. So half of 126 is 63, and I'll add those two things together. 10% plus 5% would be 15%, and then this would be £189. So this is how much she saves each month. Okay, now I'm going to write it this way. I haven't got a calculator, and I need to know if, how does it say? It says how many months will it take her to buy the car. So she already has £756 already saved. She then is going to add on £189 each month until we get to this magic amount, this £1,340. Now the way I'm going to add 189, I'm going to try and do it really quickly, is I'm going to add a bit too much. I'm going to add £200, which is very easy to add. That's going to be 956, but it's adding too much. It's adding £11 too much, so I need to take off £11. Okay, so that's how I'm adding 189 very quickly, and I'm going to get 945, and then add 200 to that would be 1145. So 1,145. Take off 11 from that will give me 1,134. So that's 1 month, 2 months, and then just preempt 3 months, 4 months, maybe 5 months as well. If it's wrong, I can go and cross out some of these after though. Add 200, so 1,334, but then taking off 11 will give me 1,323. And then again, adding 200 will take me 1,523, take away 11, 1,512. So that is the amount she needed. She needed 1,340, because this one here, the one within 3 months, was only just too low. She needed that amount there. So that's too low. So not 5 months, 4 months. I'm just going to reference what this is mentally. So I'll show you what I'm writing here, sorry. Mentally adding 189 quickly. And then I just reference here, it will take her 4 months to afford the car. Okay, next question. Graham is thinking of setting up a spinner and a dice stall at his school's open evening to raise some funds for a trip. He needs to know the probabilities so he can decide on prizes. He intends to spin the spinner and throw the dice both at the same time. The score on the the score on the spinner is added to the score on the dice to obtain the score. Find the probability that a total score will be 14. Okay, so I've got the spinner, and I can get the options 1, 2, 3, 4, 5, 6, 7, and 8 on the spinner. And then I've got the dice going down here, 1, 2, 3, 4, 5 and 6, so that's the dice. Okay, so this is setting up something called a two-way table, and then it said that the scores were added, so it says that the score on the spinner is added to the score on the dice. So you could start working out all of these, okay, so that's going to give me 2, 3, 4 and so on, okay, and so on that way. I'm asked to find where it's going to be 14, and there's only one way that I can see that it's going to make 14, which is 8 and 6. Which is 14 there. This would be 13, and this would also be 13. All the others are not going to be 14. Okay, so I've only got one that's 14. And how many options would I have in total? Well, I've got 8 outcomes here, and I've got 6 outcomes here. So to work out the total number of outcomes, you just want to do 8 times by 6, which is 48 outcomes in total. So then the probability that you get a 14, well, only one of those was 14, so 1 out of 48. Okay? Next question. So next question says, what's it say? It says, make Q the subject of the following formula. So that means get Q on its own. So the first thing I'm going to do is take this plus h squared over to the other side where it will become minus h squared. I'm then going to take the times by 3 over, and it will become the whole thing divided by 3, like that. Okay. For the next one, it says 3x all over 2 is equal to 15. So the first thing I'm going to do is take this divide by 2 over to get 3x is equal to 30, and then take the times by 3 over here, so 30 divided by 3, x equals 10. Okay, quite nice 4 marks there. And next one says complete the table above. Now you've got to take your time with this. If you rush it, you'll probably get it wrong. The best thing to do is change the x's to open brackets, and then within the open brackets we're chucking the number above it. So minus 3 is going in here. So minus 3 there, minus 3 there. Now minus 3 squared means minus 3 times by itself. So minus 3 times minus 3, and minus times by a minus is a plus. So that answer is going to go to plus 9, times that by 3 would be 27. I've then got plus 2 times minus 3, that gives me minus 6, and then I want to take away 10. So that is going to give me 27, take away 6, which is 21, take away 10, which is 11. I then need to go and plot all these points. Now you'll be able to tell pretty quickly. I know that a squared graph, in general, is the highest power is the squared. It'll do some sort of U shape. If your points go sort of like this, then something's gone wrong, isn't it? It's not going to do that. It should be sort of falling in line to there somewhere. Okay, so just be careful. If you get something like that, it means you just plotted it wrong. So use a pencil to plot always, because if you go wrong, you can then put it right very quickly. So minus 4 and 30, minus 3 and 11, minus 2 and minus 2, and minus 1 and minus 9. Okay, so that's there. And then 0 and minus 10, and 1 and minus 5, and 2 and 6, and 3 and 23. There. Okay, so now I just need to draw a smooth curve through there. Now the minimum point is at minus 10, the lowest point. It's called the minimum point. It might come up, it might say find the minimum point of the graph. I tend to go and draw, now this isn't the best one I've ever drawn actually, this isn't very good. That needs to be more curved. Oh, I plotted a point wrong. Okay, now I can tell it's wrong because, look, it's doing a weird shape like that. I'm expecting it to do something more like that. And if I actually looked at this point here, minus 2, look, that's where it should have been there, going through minus 2, that point was wrong. Okay? So just be careful. So I just showed a pretty good example of how you can get these wrong. Luckily, because I did it in pencil, if I had the time, I'd actually go and rub it out and do it again, but it's Tuesday night, it's not actually, it's Monday night, and I want to crack on a bit of a chill. So it then says, write down the x-coordinates of the points where the graph intersects the x-axis. So where it intersects the x-axis is at this point here for me, and at this point here for me. Okay? Now I've actually got different answers. I've actually done this already. By the side, I'll show you my one from before. I've actually got different answers to these. It doesn't matter what these answers are, as long as they're true of your graph. So I think I actually have the same one there. I'm going to say x equals minus 2.2. That's one of my answers. But the other one for me there is x equals 1.5. As long as they are the ones off your graph, you'll get that mark. Okay, so there's the two answers that I've written there. Okay, for the next one then, we're looking at a bit of nth term. Quite like nth term. We did this in the revision session as well recently. So what's the sequence going up in? Well, it's not. It's going down in 3 every time. So because it's going down in 3, that becomes 3n. Go and work out what this number here in front of the 12 would be. So if I'm going down in 3 this way, I must be going up in 3s that way. So that's 15. What sort of 15 plus 15? So it's minus 3n plus 15, or I could have said 15 minus 3n. Both are acceptable. The next one, then, best thing to do is actually count the tiles, unless you can see a pretty obvious shape. Sometimes they might do like squares with like just one square added on top of it, but it's not. It's just like an L shape every time. So if you go and read off the number of tiles, that's 3, then 5, and then 7. That's going up in 2, so 2n because it's going up in 2s. If it's going up in 2s this way, this must be going down in 2, so the number in front there would have been 1. What sort of 1? Positive 1. So the answer is 2n plus 1. Shading regions next. So, in fact, actually all of those are pretty nice. There's not any one in particular that's nasty. X is less than or equal to 1. So, find X, find 1. Draw a line going through that. And then label it. So, X equals 1. Forget about this less than for now. We'll worry about that after. Y is greater than or equal to minus 2. So, you find Y-axis, find minus 2. There. So, it goes through that value. So that's y equals minus 2. If you look at it, the y-axis is equal to minus 2. Everywhere on that line is equal to minus 2, which you can't see, but now you can. And then finally, y equals x. So that means every value that is whatever x is, so 1 and 1, 2 and 2, 3 and 3, minus 1 and minus 1, is just the diagonal that runs through here. So it's going to go through all the corners of those squares. It's just going to look something like this. Okay, and again, label your axes, label your graphs. Now we've got to use these inequalities to help us work out what it wanted. So it says x is less than minus 1. So everything that is less than 1, x is less than 1, would be everything this side. So I shade the side that I don't want, so I shade this side. Y is greater than minus 2, so it wants everything above this, this line here. If it wants it greater than that, so that means I don't want everything here. And then finally, we want y to be greater than x. So you pick a point somewhere. So I could pick this anywhere I want to do. I'm going to pick a nice point. So let's try 2 and minus 2. Okay. So 2 is the value of y, and minus 2 is the value of x. So if I write those down from here, y is less than or equal to x. I've just got to find out my y value is 2. Is less than or equal to my x value here is minus 2. Is 2 less than or equal to minus 2? No, it's not. So it's not the side I want. So that means I must want everything this side of the line. So that means this is the side of the line that I don't want. Hence, I shade the side I don't want. Okay? It will always make some sort of like, if you've got 3 lines, it'll make a triangle. If you've got 4 lines, you'll have a 4-sided shape somewhere. Okay? But it says, use the word below. It says, usually it's something like indicating clearly the region that represents your answer. So the best way to do that is just to put the letter R there, and then it's really clear, isn't it? Okay, for the next one, we've got quite an easy inequality to solve there. These are just like equations. We don't want this to ever be negative. We take the 3x over, we get 5x is less than 40, and then take the 5 over, so x is less than 40 divided by 5, so x is less than 8. They're exactly the same as equations, you just have to put this sign throughout. If you put an equal sign, you'll lose the marks. Next question. Says Katrin and Susie both have necklaces with chunky beads. They notice that they have the same type of beads but different types of numbers of each bead. The beads are either cubes or square-based pyramids. All the cubes are identical, all the square-based pyramids are identical. The girls take off their beads and they find this thing out. Okay, they obviously got too much time on their hands. They're looking at this, not really interesting. So Katrin, she's got 1, 2, 3, 4 of the square ones that I can see, plus 1, 2, 3, 4, 5 of the triangle ones that I can see, and that comes to a total distance of 38.8. Whereas for Susie, she's got 1, 2 of the square beads, adds 1, 2, 3, 4, 5, 6, 7 of the triangle beads, and that comes to 35.6. So this is simultaneous equations, okay? I am going to leave that one as it is, and I'm going to double this one to get a new equation. So this is equation 1 and equation 2. I'm going to make a new equation, equation 3, which is going to be double of this one. So 4s plus 14t, and then double of 35.6. So double of 35 is 70, double of 0.6 is 1.2. So it's going to be 71.2. Okay, now I've got the s's the same. I want to sort of ignore equation 2 in some respects. Don't actually cross it out. I'm just saying we just ignore it now. I want to make sure that I get the t's positive. So the way I'm going to do that is I'm going to do equation 3, take away equation 1. So 4s take away 4s, gone. 14t take away 9t, so I give the answer there. 14t take away 9t, I said it again. 14t take away 5t is 9t. And then 71 take away 38.8, well that's probably not worth me trying to do my head, so 71.2 take away 38.8. So all of these little skills are really important, you haven't lost over the years. 2 take away 8 you can't do, you have to borrow one. 12 take away 8 is 4. 0 take away 8, again I can't do, so 10 take away 8 is 2. 6 take away 3 is 3, so it's 32.4. And then I need to work out how many 9s fit into that. So I'm going to do bus stop division by here, 32.4. How many 9s go into 3? None. Into 32, we carry that across to the remainder, is 3 remainder, so 3 times 9 is 27, so a remainder of 5, and then how many 9s go into 54 is 6, so t is equal to 3.6 centimetres. Now I know that, I'm going to sub that into the easiest one, which is probably the top one. So I'm going to say sub t equals 3.6 in equation 1. So we're going to get 4s plus 5 lots of 3.6 is equal to 38.8. Smart way to do this in your head, times it by 10 and divide it by 2, because 10 divided by 2 is 5. So times that by 10 is 36, half it is 18. So 4s is equal to 18 and 38.8. Take away 18 from there is quite nice. That's 20.8. And then to divide by 4, halve it again. So half it would be 10.4, half that would be 5.2 centimetres. Okay, so there we go. Calculate the length of an edge of a pyramid and the length of the edge of a cube. There we go, done. Oh, okay, right, triangle, that's a pyramid, isn't it? So pyramid, can never spell this word, pyramid, and then this one was the cube. Okay, so useful to go back and just make sure you have answered what's said. Right then, the next one, I think this is actually going to be important, I still have those answers. It says, Katrin's necklace is 80 centimetres long. Calculate how many extra beads she can place on her necklace. Well, we know that her necklace already takes up 38.8 centimetres, so it's Katrin's, so 38.8. Plus her spare bit of necklace, but it must come to no more than 80. It can't be more than 80. In some respects, I could put an inequality sign there and say equals 80, but I'm not going to bother. I'm going to leave it as that. I'm then going to work out exactly how much spare necklace there is by taking over the 38.8. And I'm adding up 38.8 to get to 80 in my head. So 0.2 would be 39, then 1 would be 40, so it's 41.2. But obviously you can use like other methods to do that if you want to. And then it says how many of the cube beads. So I worked out the cubes were 5.2. So I need to work out now 41.2 divided by 5.2 and see how many of those fit in there, but I haven't got a calculator. So to do that, I'm going to times top and bottom by 10 and just keep it as an equivalent fraction. It's still the same thing. For instance, if I had 6 divided by 3, I know that answers 2. That's the same as 60 divided by 30. That answer's still 2. It's an equivalent fraction. You don't need to do anything after. I'm now going to halve top and bottom to get 206 over 26. Still even. I'm now going to halve each of those again, so that's 103 divided by 13. Now I don't know what that is, so I'm going to set up bus stop division now. So 103 here. How many 13s go into 1? 0. Into 10, still 0, so this didn't actually help me out at all. How many 13s go into 103 then? Well, let's write out the 13 times table if you need to. So 13, 26, 39, 52, 65. So I'm just repeatedly adding 13 to itself here. 78 and 91, and then the next one's going to be 104, isn't it? So it's 1, 2, 3, 4, 5, 6, 7. It's 7, and then quite a lot of remainder. It was remainder 12, but 7 point blah blah blah. So I can only fit in 7 anyway, even though I can fit in 7 and a bit. It's 7 cubes can be added. Okay. Next question. So write these numbers in ascending order. Well, the best thing to do is get them all in standard form. That's in standard form, that's in standard form, that's in standard form. That's effectively like 1 times 10 to the 3. This one needs to be in standard form. It is 1.2 times 10 to the power of 3. Not 2, because there's 2 zeros. Decimal point has gone in between the 2 and the 1, isn't it? So there's 1, 2, 3 numbers there, hence the power of 3. So what's the smallest? Ascending means the smallest. In fact, they told you that. They shouldn't tell you that. They should make you try and work a bit more than that. That becomes... that's the smallest because its power is the smallest. So it's that one. Now these are all to the power of 3, aren't they? So what's the smallest number here? It's that 10 to the power of 3 next, because it would just be 1 times that. Then that one, which was originally 2,100, because that's smaller than that. And then this one, 2.4 times 10. It's not, 2.4 times 10 to the power of 3, that one. Okay. Evaluate 6 times 10 to the 13 plus 9 times 10 to the 13. Now there's a long way to do this and an easy way to do it. The long way to do it is to say, right, that's 9, and because it is the power of 13 and there's no decimal point or anything, it would be 13 zeros there. Well, that's going to be a long time to write out. And the same with this one, it's going to be 6, and again, it's going to have a load of zeros there. If you add those together, we're going to end up getting 15 and 9 zeros there. Okay? So to do that, I'm going to get a decimal point there, and I would have the 9 zeros, and this number would tell me it's 1.5 times 10 to the 14. That for me is actually maybe not that bad the way I've explained it there, but that's for me. The other way to do it, you can only ever add numbers together in standard form if they have the same power. If they don't, you have to do this method, but they don't usually give you such rank indices as 13. So if it was another way of doing it and they had the same power, you literally just do 6 add 9, which is 15, and then it would be times 10 to the 13. Those numbers actually stay the same. That's not in standard form because it's a number bigger than 10. So to make it a number smaller than 10, I divide that by 10, but to counteract that, I need to times it by 10. So that becomes 1.5 times 10 to the 14 also. It depends which method you prefer. Like I say, I don't mind that way, but some people don't like that way at all. Some people prefer this way, and if it means write out a few more zeros, they'll write out a few more zeros. For the next one then, now this one I thought was quite hard actually. I didn't think this was an easy question at all. The formula that I've taught my class is y minus y1 equals mx minus x1. Okay, if you're unsure how to use that, then you'll have to do whichever method your teacher has shown you. Okay, so that's going to be important, and then I need to start reading what the question says because I'm not at the moment. It says, use the following to find the equation of a straight line. The point that is halfway between 320 and minus 316. So halfway is the midpoint formula. So I do x1, add x2, and then I divide that by 2. And then I do the y coordinates added together and divide that by 2. Okay? So what I'm going to do to begin with is I'm going to do 3, which is that x coordinate, plus this x coordinate, so 3, add minus 3, and then I'm going to divide that by 2. I'm then going to do 20, add 16, and divide that by 2. Now, a quicker way to think about this if you're ever unsure is basically, if you're on 3 and minus 3, what's in the middle of that? Well, the answer is 0. Otherwise, I could have said 3 add minus 3 is actually, like doing 3, take away 3, which is 0, 0 divided by 2 is 0. What's in the middle of 20 and 16? Well, it's obviously 18, isn't it? But if it wasn't obvious, you just do 20 add 16, which is 36, divided by 2, which is also 18. Now, we know this point is on the line. Another point on the line, so that's 1 point. And then another point, we're told, is minus... now, we're not told. It says, when minus 110 is reflected in the y-axis, it gives another point on the line. Okay, well, I probably need to draw that to get my head around what's going on here. So here's my axes, here's y, here's x. Minus 110 would be across to minus 1 to x, and then 10 there. So that's minus 110. And that's reflected in the y-axis, so it's going to be over here. So it's 110. Okay? So another point equals 110. Now from here, to start using this formula, I can use either of these set of coordinates. It doesn't actually matter which one for my x1 and my y1. I could either call this one x1, y1, or I could call this one, well, I'll call it x2 and y2, but it doesn't actually matter which coordinates go in here. But I need to go and work out m. M is the gradient. So, am I told something else here? I thought I was. So, it says when minus 1 is reflected in the point, straight line. Oh, okay, yeah, 0, 18, yeah, 0, 18. So I'm just going to plot 0, 18, which, let's say that is there. 0, 18, so across to 0, it's physically on there, 18 there. So I need to go and work out the gradient of that bit there. Now I'm going down here, so that's telling me I've got a negative gradient. So to work this out now, I'm going to use what you like to use, which is rise over step. So I've risen from 10, I've gone up to 18, so that is a rise of 8. And my step, I've gone from 0 to 1, which is just 1. But I've already said this is a negative gradient, so it must be a minus answer. So my gradient is minus 8, and that is what we call m. Okay? So now I can chuck this into this formula, say y minus y1. So I'm going to use these coordinates here, y minus y1. So y minus 18 is equal to the gradient, which is minus 8. And then x minus x1, so x minus 0. So that becomes y minus 18 is equal to minus 8x, and then minus 8 times 0 is nothing, so I don't need to write anything at all there. And then from here, I want to take the minus 18 over, and it will become plus 18. It's now written in the form y equals mx plus c. Okay, but a tricky question, it's not the easiest thing in the world, bit harder than some ones we've looked at in class as well. Okay, and then on reflection, this is much easier. Okay, so 10a. Rotate the square 90 degrees clockwise about the point 2, 1. So you need to go and plot the point 2, 1. So there's 2, there's 1. So you go across the 2 up to 1. Now the way I teach it is to go and draw a crosshair by there. The whole point of doing that is that'll start splitting it into 90, 180, 270, 360, a lot of them. Okay? You need tracing paper, you'll have tracing paper in the exam. If you haven't got it, ask for it, you're allowed it. Okay? Draw the crosshair and the shape. Now I tend to just do the corners myself, but I'd recommend doing the whole shape if you're unsure. Which I am going to do. But when I just do it by myself, just to get answers for something, I'll just end up tracing just the corners if you like that idea. So I'm doing it 90 degrees clockwise, and clockwise would be this way because that's the way the hands spin around a clock. I put my pen on that and I look for it just to cross over on itself once, which is there. Okay, so that is that point there, 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 and there. And then just peel away your paper and make sure that you've got the same places marked. So then there, there, there. Make sure you use a ruler for this as well. If you don't use a ruler, you can lose a mark. And then let's just check I've got it. Perfect. Okay. Now, gut feeling is we've probably not seen a huge amount of negative scale factors before. They're quite easy. They just do the opposite of what you expect. So it says using 0, 0 as the centre of enlargement, so that's here, I need to then enlarge it by minus a half. So what I do is I pick my first corner. How do I get to there? Just going up or down, left or right? Well, I go across right twice and then up twice. So across twice, up twice. I now want to make that half as big, but I do the opposite. So rather than going to the right, I'm going to go to the left once. So I go left once and down once. Now I could do that for each of these things here and then say, right, how do I get here? I go up 6 and across 2. So I want to go down half of that, so down to 3 and then across 1. This one here, up 6, across 6, so now I want to go down 3 and across 3. And then lastly here, across 6, up 2, that's going to make me go across 3 and then down 1. Okay, and then the way to check it is through your centre of enlargement. you join these up, and they should meet up. You don't have to do this, it's a way of checking, but if they didn't meet up, it'd be wrong. And then, as you can see there, do this one a bit fainter so it doesn't go through the shape there. I do have a small issue here. If I plotted that one correctly, yeah, I think I'm just off a tiny bit. I'm not being very accurate. Maybe it's 'cause it's Monday night. So let me check. That is 6 and 6, so that should be -3 and -3. No, I have plotted it fine. I'm just being like a little bit overly cautious here. Should have been a bit more accurate when I went through there. Okay, then getting towards the end now, we've got quite a nasty circle theory question. This is a radius and this is a tangent. That always meets at 90 degrees. So I'm just going to reference there. Tangent meets radius at 90 degrees. Then I can see here, look, I've got a four-sided shape. So how many degrees are there in a four-sided shape? 360 degrees in four-sided shape. I know 2 of them already. I know, well actually I know 3 of them, 90 and 90, and I know 30. So 90, add 30 comes to 210. So that tells me this angle here. So I'm going to say therefore BOC, I'll just put a little hat on O, you don't need to, it's going from B to O to C, is equal to, so 360 minus the 210, which is what, 150? 150 degrees, and that's due to this fact here. Okay. Now, what was I asked to go and find? I was asked to go and find BAC. So B to A to C is this angle here. So I'm going to put 2 lines there to show it's not the same angle as that one there. And I know that BAC is equal to 75 degrees. I know that because angle at circumference. Because angle at circumference equals half angle at centre. Okay. Let me just double check that's all good. Yes, lovely. And far off being done now. Easiest mark in the entire GCSE paper, evaluate 19 to the power 0. Okay, it's 1. 2 ways to do this. I'll show you both ways because there's a really neat way to doing that. The long way is to say it's root 80 minus root 5 times by itself, which is root 80 minus root 5. That's going to be root 80 times root 80, which is 80. Root 80 times by minus root 5, which would be minus, so you do 80 times 5, so 8 times 5 is 40, and then add another 0 from there, goes in there. Then minus another root 400 from this one here, and then plus, because minus times a minus is a plus, and then root 5 times root 5 is just 5. So this becomes 85 from the 80, add the 5. Take away the square root of 400, don't know, square root of 4, 2. So the square root of 400, it's not 200, because 200 times 200 would be like, 40,000, is actually 20. Okay, so take away 20, take away another 20, and then that answer comes to 45. The quicker way to spot it is what square number do you see that goes into there. Now, this won't be everyone's cup of tea, I like this, but some people don't. If you look at the 5, I bet you 5 goes into there, and it does, because it ends in 0, and it's 16 times by 5. So that's 16 root 5 squared. The square root of 16 is 4, so it's 4 root 5, take away root 5 squared, which is then 3 root 5 squared. That means it's 3 root 5 times by 3 root 5. 3 times 3 is 9, root 5 times root 5 is just 5, and then 9 times 5 is 45. Believe it or not, even though it's more working, I prefer that way, but it depends what your preference is. Okay? Part C. Now, because there's 2 dots on here, that means it's recurring twice. So I'm going to times this answer by 100. I'm going to have x, I'm going to have 100x. Okay, but this is the way I start to set it up. It's all important that you get your equal sign and your decimal signs set up. Now, ignore the 100x for now. Okay, x is whatever this is. It's 0.42828 blah blah blah. Okay, now timesing that by 100 will shift all of these up 2 places. So that'll become 42, and then an 8, and then a 2, then an 8, then a 2, then an 8, blah blah blah. Okay, so times them by 100 shifts all of those so those 2 8s match up. I then subtract those 2 things. So 100x take away x is 99x. These cancel, 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 cancel until here. 8 take away 4 is 8. 2 take away nothing is 2. 4 take away nothing is 4. Now there's a problem here with my answer. When I take the 99 over and divide by 99, I've got something that you should never do with a fraction. You shouldn't have decimals in a fraction. So all we do is we keep the fraction equivalent by times on top and bottom both by 10. So x is equal to 424 over 990. Okay? This one here is just like what I did up with the surds, this time using pi, and you just don't write out with pi, so you use it like an x. So you're going to get pi times pi, which is pi squared, pi times minus 3, which would be minus 3 pi, pi times by plus 3, so plus 3 pi, and then plus 3 times by minus 3 becomes minus 9. These things cancel, leave me with pi squared minus 9. Okay? It's called the difference of two squares, this thing, when you have the same thing plus an exactly the same thing but then a minus. And last page, bit of probability. Now, I don't actually think this is on the numeracy paper. You sort of go through anyway, because it could come up in the maths one, which is next week, but by all means, stop there. I think this will be fine. Okay? It says, calculate the probability that both the beans are black-eyed beans. And we're told something really important here. We're told these are without replacement. Okay? I should read the question beforehand, but pause the video, read the question. That bit's really important. So, what's the chances that I get a black-eyed bean, first of all? Well, I've got 10 out of 25. You then multiply it by the probability of getting it again. Now, because it's not replaced, I only have 9 when I go in the second time, and then 24 here. Now, I'm not thrilled at trying to do 10 times 9. Well, I can do 10 times 9, suppose, but 25 times 24, I don't expect you to know off the top of your head. It may be useful to try and cancel down this fraction if you can. So 5 goes into both of those, so 2/5. 2 times by 9 is 18, and then 5 times by 24, not sure. 10 times by 24 is 240, and then 5 times by 5 must be half of that, so 120. No need to cancel that down. You could have written, I could have had 90 over whatever the other one was, which I think is 600. It's fine. That's still correct. It doesn't say anywhere that you need to cancel down, so don't worry about cancelling that down. Calculate the probability that at least one pinto bean is selected. The way you set this up is very, very subtle. So because I'm only interested in pinto beans, I'm going to say pinto bean or P, and I'm going to say P bar, which means not a pinto bean. And then from there, I'm either going to get a pinto bean or not a pinto bean. Same here. Pinto bean, not pinto bean. Okay? Chance I get a pinto bean, 9 out of 25. Not a pinto bean must be whatever's left then. So 25 take away the 9 comes to 16. So 16 out of 25. So these two fractions should always have the numerators add up to whatever the denominator is. Now, say I pick this pinto bean, there's only 8 left out of 24. Here, there would still be 16 left of the other ones, but there's 24 in total. Again, 8 out of 16 makes 24. Here, say I didn't pick a pinto bean, that means there are 9 of them still in there, and there's 24 in the second pick. That means there'd be 1 less non-pinto bean to get that. And again, 15 add 9 makes 24. Okay? Now I'm interested in at least 1 pinto bean. So this is ground, that's 2 pinto beans. This is at least 1, this is at least 1, but that one doesn't count. 2 ways of doing it. You find all of these probabilities and you add them all together. Quicker way is to say, right, this is the only one that doesn't work. So 16 over 25 times by 15 over 24. Now, I'm going to do what I think is a very clever way of making this easier. I'm going to do the same cancel that I did there, but because I'm timesing, I'm just going to do it across the fractions. So I know that 5 goes into both of those, so 5 goes into them 3 times, and it goes into that 5 times. I know 8 goes into both of those. I know it goes into that twice, and I know it goes into that 3 times. And then this will give me the cancelled down version. So 2 times 3 is 6, and then 5 times 3 is 15. Now I know that all probabilities must add up to 1. So if I do 1, take away 6 over 15, that will give me 9 over 15, which is what all of these would have added up to. And it's like maybe a quicker way to get there. And that concludes the paper.